My topic is blending virtual and real to refresh classrooms, how VR and AR technologies make education and learning more effective. In today's era where digital technology is rapidly integrating into campuses, the traditional classroom model of teachers lecture and students listen is increasingly struggling to meet people's demands for vivid and flexible learning. Immersive, interactive technologies centered on VR and AR with their ability to create realistic scenarios and support real-time interaction have broken down the barriers between textbook and reality, bring brand new changes to education and teaching, and transforming learning from tedious knowledge memorization into an engaging, immersive experience. The greatest benefit that VR and AR technologies bring to education is their capacity to make abstract knowledge visible and tangible. In the past, when studying history, students could only imagine ancient life through textbook text. When learning biology, they relied on flat illustration to understand cell structures. When studying geography, they guessed celestial movements based on maps. With VR technology, however, students can put on dedicated headsets to travel back to ancient Egypt. Watching craftsmen transport huge stones to build pyramids with their own eyes and experiencing the wisdom of ancient civilizations. They can also step onto Mars, tread on red sand, observe Martian landforms, and intuitively grasp the principles of planetary motion. AR technology, on the other hand, overlays virtual content onto the real world. When students scan cell illustrations in biology textbooks with devices, three-dimensional animation of cell division will appear on the pages, and they can even zoom in to view the operation of mitochondria and cell nuclei with hand gestures, making the once distant microscopic world instantly close at hand. The Smithsonian Institution abroad has developed an AR cultural relic database, allowing students to touch precious collections from dozens of museums up close anytime and anywhere without visiting physical museums, turning historical and artistic knowledge from cold words on paper into vivid experiences. Improving learning safety and resources utilization is another prominent advantage of VR and AR technologies in education. In traditional science experiment classes, content such as flammable and explosive chemical reagents, high-voltage physical circuits, and medical human anatomy not only carry significant safety risks but are also limited by equipment cost and venue size, making it difficult for every student to get sufficient hands-on practice. VR virtual laboratories perfectly address these issues. Students can rapidly conduct dangerous experiments in a virtual environment, freely adjust the reagent ratios, and carefully observe reaction processes, eliminating safety hazards while thoroughly understanding experimental principles. The chemistry teaching VR platform built by the United States Air Force Academy has increased students' experiment participation rate and knowledge mastery by than 30% compared to traditional classrooms. AR technology can also reduce waste of experimental consumables. Data from domestic AR physics, chemistry, and biology experiment system shows that after adopting the system, the consumption of experiment supplies decreased by 60%, where the experiment success rate rose to 92%, greatly improving the efficiency of teaching resource utilization. VR and AR technologies also help realize personalized learning and promote education equality. Every student has different learning paces and cognitive characters, and traditional collective classrooms struggle to cater to individual needs. However, VR and AR technologies can flexibly adjust content difficulty based on students' learning performance. For example, VR applications for language learning can build virtual foreign language communication scenarios for students to have real-time conversations with virtual characters, and the system will push targeted exercise based on pronunciation accuracy and grammatical errors. For students in special education, such technologies are even more helpful. Autistic students can practice emotion regulation and communication skills in virtual social scenarios through VR programs. Visually impaired students can perceive the structure of virtual models with the help of AR voice interaction and tactile feedback, making up for learning difficulties caused by sensor impairments and truly ensuring that no student is left behind. In addition, VR and AR technologies can enhance classroom interaction and cultivate students' practical abilities. In the past, classrooms were dominated by teachers' lectures, and students were mostly passive listeners. However, the interactive scenarios built by VR and AR have turned students into the protagonists of learning in VR virtual design studios. Art majors can independently carry about 3D modeling and modify design schemes at any time. In AR physics classrooms, students can personally build virtual circuits, and the system will immediately feedback current data to help them understand circuit principles. This learning by doing approach effectively trains students' practical operation abilities and critically thinking skills. In the field of vocational education, many VR training platforms can simulate scenarios such as medical care, mechanical maintenance, and agricultural planting, and trainees can obtain professional skills certificates immediately after completing courses, achieving a seamless connection between learning and employment and enhance the practical value of education. Of course, the popularization of VR and AR technologies are campuses still face challenges, such as high equipment cost and insufficient high-quality teaching content. But with the increasing portability of technology and deeper cooperation between schools and technology companies, those problems are being gradually resolved. Lightweight AR glasses and all-in-one VR headsets have lowered the application threshold for schools, and teaching resource libraries co-built by universities and enterprises have entered immersive learning content across various disciplines. In the future, if AI is deeply integrated with VR and AR, the system will be able to generate exclusive learning scenarios based on each student's learning situation. And immersive education will then evolve from a simple tool into a complete new education model. From virtual historical spots to the tiny scientific world, from safe experiment steps to personalized skill training, VR and AR immersive technologies are changing how education works. They are not just a new version of teaching tools, but also better ways of thinking about learning. They turn education from passing on knowledge to building learning experiences and lay a strong teach basis from raising creative talents who can fit the future. Thank you.